Welcome. In this session, we'll learn the equivalent circuit of a capacitor if it has some initial value. Let's start. Let's suppose we have a capacitor which is initially charged to some voltage V0. All right. So this has an initial voltage of V0 value, and what we do, we want to connect to this apply a source to this capacitor at time t equal to 0. So what is the behavior of the voltage across this capacitor? All right, that's what we want to find out. We want to find out the full behavior of this capacitor voltage after for t greater or equal to 0. All right, we know the value of the capacitor voltage means Vc of 0 is equal to V0. That's given to us. All right, so to find the value of the capacitor voltage, what we'll do, we write Vc of t is equal to 1 by c integral minus infinity to t Ic of t dt, where Ic is the current flowing through this capacitor. So we can write it like this: 1 by c minus infinity to 0 Ic of t dt plus 1 by c integral 0 to t Ic of t dt. Now, if you have a look at the first integral, this is simply the voltage stored in the capacitor at time t equal to 0. At time t equal to 0. So this is simply as Vc of 0 plus 1 by c integral 0 to t Ic of t dt. But Vc of 0 is given to us because this is equal to V0. And we can write it as 0 to t Ic of t dt. So this is the voltage across the capacitor as the time progresses. So V0 Vc of t at an instant is given by this. So we can draw the equivalent circuit of this capacitor. So we can draw the equivalent circuit of this capacitor like this. So the equivalent circuit of the capacitor can be drawn like this. So the capacitor voltage is equal to, there will be one capacitor and there will be one voltage source, and that voltage source is having a voltage of V0. And this is our capacitor, and this will be our behavior of this capacitor voltage for t greater or equal to 0. So this is the equivalent circuit of the capacitor for t greater or equal to 0 if it has some initial voltage stored in it. So what do? We simply replace the capacitor by a voltage source in series with this capacitor, and the voltage in this capacitor is governed by this part of the equation from 0 to t, because we are connecting this source at t equal to 0. So that part is governed by this integral, and the total voltage is V0 plus this part, and the sum will be equal to this Vc of t. All right, this is the equivalent circuit of this capacitor for t greater or equal to 0 if it has some initial voltage. In the next session, what we'll do, we will summarize the points about this capacitor.